Okay, so in this video, we are going to talk just briefly about some more geometric relationships. So you can, if you've printed out the toolkit from the website, you can add that to your toolkit. If you have not, you can add this just directly to your notes. So there's a couple of theorems that we still want to talk about. So one of the first ones is what's known as the triangle sum theorem. Okay, so the triangle angle sum theorem basically states this: the sum of all of your angles, angle measurements in a triangle are always equal to 180. So basically, what that means is that if I add up my angle 1, my angle 2, and my angle 3, it's going to equal 180. Now, how can I use this information, right? Well, if I just draw any old triangle, okay, and I give you one measurement, so I give you that this is 20 degrees here, and I give you a second measurement that this is, say, 100 degrees here, how can I figure out what this angle is? So we'll call it angle A. Well, I would say that angle A plus 20 degrees plus 100 is equal to 180. This will give me 120, right? And if I subtract 120 from 180, I will then get my measurement for angle A as 60. So again, you can easily find that third angle. Now, the other thing that we can look at with this is I can ask you, is it a triangle or not, right? So I'm going to say triangle or not, right? So based on this information, if I say that this is 40 degrees, and then this is 50 degrees, and then this is 60 degrees, is this a triangle or not? So we can test this out. We can say 40 plus 50 plus 60, does it equal 180 degrees? Question mark. Well, 40 plus 50 is 90, and 90 plus 60 is 150. So is the right side and the left side equal to each other? No. So this is not a triangle. Now, if I give you two angles, we can easily find the third angle. Would this work if I gave you two sides instead? So we're going to talk about what's known as the triangle inequality conjecture. So we didn't really prove the triangle angle sum theorem, but we want to know, can we use this information to create the sides of the length of a triangle, right? So basically, if you know two side lengths of a triangle, can you determine the length of a third side? That's really what we're trying to figure out. Okay. So when we look at this triangle, okay, I see that it is not a right angle, okay, so I can't use Pythagorean theorem, okay, and I'm going to go ahead and I'm going to create a new triangle, but with my own lines. So boom, something like that. Let's make this a little bit smaller, something like that. Okay, so what we're trying to figure out is what is this length, right? What could possibly be this length? Okay, so again, this is 8 and this is 6. Well, right now, I know that it creates a triangle. I can create my triangle, right, by connecting those pieces together. Well, what happens if I expand this 6 out a little bit? So let's move the 6 out. And I'm going to bring this down. This is still becoming a triangle, okay? I can still connect the points together, right? So it still makes a triangle. It just means that my angle got really, really large. But I'm going to continue to pull the 6. I want the 6 to actually match up with the 8 really fast to the best of my ability. So I'm going to pull that 6 down, and again, still making a triangle. But what happens if it looks like it becomes a straight line? Okay, remember, straight angle pairs give you 180 degrees. Can you have a triangle, that horrible looking triangle, but it's okay. If I have one angle be 180, what do the other two angles have to be? 0 and 0. Does that make sense? And hopefully you're shaking your head. No, that doesn't make sense. So I can't quite make these two sides, go all the way into one line. So I know that this triangle, the CA, has to be smaller than 14 centimeters, right? Can't equal 14 or it's a straight line. Okay, so let's go backwards. Let's do it the other way. Okay, so what happens if, let me erase all this too. What happens, oh, I erased the 8. I didn't mean to erase the 8. What happens if I move the 6, and again, I start bringing it up. Actually, let's see if I can change the color. Change the color. So if I bring it up, again, it makes a triangle, makes a triangle, makes a triangle. So I still have an angle, but what happens if I lie my triangle right on top of my other triangle? What kind of angle did this make again, right? And hopefully in your head you said 180. So how long is this triangle? Well, I know I want to find the difference between 8 and 6. So I know now that CA has to be larger now than that number 2. Okay? So this triangle inequality conjecture, right? What we're trying to do is find two side lengths of a triangle, right? So I want you to write this down. If we know two sides of any triangle, then the third side range can be found by solving these two inequalities. And I'm going to say, here's just a general triangle. We're going to call this A, we're going to call this B, and we'll call this C. So A, B, and C are just sides. So C has to be smaller than whatever A plus B is, and C has to be larger than whatever A minus B is. Now, A and B are just any two sides of a triangle. C is just the third side, so it has to work for all of them. Okay, so let's test this theory out and see what we get. Okay, so let's take a look at this. We're trying to figure out, could we build this triangle? Okay, so if I create a triangle with these sides, 5 and 3, could this really work out? Okay, so let's test it out. If I take, let's just take the first two numbers. So 5 plus 3, that's going to give me 8. Is 8 larger than 10? And the answer is no. So because it doesn't satisfy, right, the first set of inequalities, then I know that this cannot be a triangle. I could also, right, subtract, right, some numbers together, right? So let's subtract 10 minus 3. And again, when I subtract the 10 minus 3, that has to be smaller, right? So this has to be smaller than the remaining side, which is 5. So 10 minus 3 gives you 7, and 7 is not smaller than 5. So this is not a triangle. Now, one that is a triangle, right, could possibly be 3, right? So this could work out, because if I take 5 plus 2, that is going to be smaller, larger. I don't know why I wrote smaller. That is going to be larger than 4, okay? Or I could do 2 plus 4, that's larger than 5. Or I could do 5 plus 4, that's larger than 2. So it all works out, right? So if I did 5 plus 2, I could also test out 5 minus 4, right? Has to be smaller than 2. 5 minus 2 has to be smaller than 4. And then the last one is 4 minus 2 has to be smaller than 5. So notice that they're notice that these all kind of do work out. Now our third one is this, right? So again, it's a conjecture. We haven't proven it yet, but it does work out. Longest side goes with the largest angle. So basically, right, what I want you guys to write down is this. If an angle is the largest in a triangle, then the longest side is opposite to it, right? If it's the smallest, right, then the shortest side is opposite of it, right? And again, vice versa, we can just say the side is the longest side, then it goes with the largest angle, and so forth, right? So again, you can kind of copy this picture down. Notice that angle B is the larger side, or sorry, larger angle 127, and notice that the larger angle side is number 9. The smallest side is 4. Notice that the smallest angle is 21, right? So longest side goes with largest angle, and we can always look at that. Think about your think about your right triangles, right? This is a 90 degrees, and your hypotenuse is always your largest side, and it's always across from 90 degrees. So you guys have already kind of been using longest side, largest angle, but you might not have actually known about it. Okay, and that's all. That's your geometric relationships.